So before we get to graphing, let's actually understand a concept real quick. So let's say I have the numbers 1, 2, 3, 4, 5, 6, 7, and so on. Now let's say I do the reciprocal of those numbers. So the reciprocal of 1 is 1 over 1. The reciprocal of 2 is 1/2, 1/3. The reciprocal of 4 is 1/4, 1/5, 1/6. And as we go on, this continues. When we look at these, when these numbers are getting bigger, these values are actually getting smaller. Think about it. 1/3 versus 1/6. 1/6 is a lot smaller. 1/7 is a lot even smaller. And then it keeps on going. So these numbers are getting smaller as these numbers are getting bigger. The same thing's happening if this was sine and then its reciprocal is cosecant. As the values of sine get bigger, the values of cosecant are getting smaller because cosecant's reciprocal of sine. And so that actually plays into what the graph of secant and cosecant look like, because secant and cosecant are reciprocal of sine and cosine. So what we're going to do is we're actually going to graph as if it was a sine or as if it was a cosine. It's just in the end, the very, very end of the graphing, where normally we make a curve, that's where our graphing changes. So let's look at an example. Let's say I have y equals 2 sine 1/2 x plus pi over 2 minus 1. Okay, so that you can graph this. You should be able to graph, but you should be able to graph sine, but we're going to change it up. We're not going to have sine, we're going to have cosecant. Okay, so it's just like graphing sine. We're going to go through the exact same steps. We're going to do our notes. The amplitude would be 2. The period is 2 pi. Divided by 1/2, flip that over, we actually get 4 pi. Width of the quarters, we're going to go back to that, is just pi, because we take 4 pi divided by 4. Our phase shift, do we look inside, is going to be pi over 2 to the left. Our vertical shift is going to be 1 down. Okay, so we have to graph all that. 1 down, amplitude of 2, phase shift of pi over 2 to the left. All right, so let's not make it that close. Move it up here. Okay. So, as far as the axes go, we're at pi over 2 to the left. So we start at negative pi over 2. And then I have to add on my width of my quarters every time. So now we're at pi over 2. Then add another one. We're at 3 pi over 2. Add another one, or 5 pi over 2. So basically pi is the same thing as 2 pi over 2. So I'm adding on 2 pi over 2 every time. I need one more. And we get 7 pi over 2. We have a vertical shift of 1 down, so I'm going to make my dotted axis there now. My amplitude is 2 up from there, so I go up to 1, I go down to negative 3. All right. Now, for the graphing part, I'm going to put my dots just like I would have before. So this is the reciprocal of sine. So sine normally starts at the axis, goes up to the maximum, axis, minimum, axis. Now don't forget we're graphing cosecant, and cosecant's reciprocal. So let's just take a moment and point out the axis. Let's just say that we're on the regular axis. What that means is that sine at that angle is 0. So cosecant at that angle then would be 1 over 0, which we can't have as undefined. So we have to put an asymptote. Wherever sine cross the axis, or cosine for that matter, then for the reciprocal we're going to put in an asymptote. Okay, so now all of a sudden we've got all kinds of asymptotes in our graphs, which means also that our graph is going to go on forever hugging the asymptote. Now if you remember, let me do this in green. Normally sine went like this, right? Normally sine went that way. However, this is the reciprocal. So where our graph was normally going up, now it needs to be going down. But in order to hit this spot and hug the asymptote, it's going to be going down up here. So it was going up here, now it's going to be going down. So we're going to get something that actually somewhat looks like a parabola, only a parabola keeps getting wider and this doesn't because it's going to be hugging the asymptote. And then before, sine would have come down like this, so it's coming down, but we need it to be going up and still go through that point, so we need it to go right here. So this is what cosecant looks like. The graph of sine would be in here, just like this, but in blue is what cosecant is. So Again, reciprocal. So when it's going up here, that means cosecant needs to be going down. When sine was going down, cosecant needs to be going up. When this is going down, cosecant's going up. When this is going up, cosecant's going down. And so we get these things that kind of look like parabolas. And then it would keep on going like that. My next one would be up here, and then it would be down here, and so on. And so that's how you graph cosecant and secant in general. There's really nothing else to it. You already know how to do this. You already know how to get these. It's just a matter of graphing these differently. And then wherever you're on the axis, you do a dotted. Good luck.